Really? Good afternoon. What did it just do? I didn't pick. All right, now Clever is acting very strange. Just got kicked out of Clever. All right. If I can get back to Clever, we are going to start soil today. So we've been looking at land, the lithosphere, all righty. Good afternoon. All right, so last class we looked at soil formation. Today we're going to look at soil composition. Learn a little something about this good old red Georgia clay. All right, almost everybody's here. All right, so if you're log into Canvas and go to 4.3 and take a look at that while we're waiting for folks to come in. The other thing that has happened with me ever since they upgraded, I have to find all of my saved shortcuts again. I have a totally different desktop. Come on. All right, so again, if you would be looking, just read over this section on 4.3. We're going to watch that, and then if I can get my AP Classroom to behave. Why is it doing that? Oh. Okay. Oops, what did I do? There's something I shouldn't have. Try this again.
Hey everybody, it's Mr. Smead. Today we're talking about topic 4.3, which is soil composition and properties. So in video 4.2, we focused on what soil is. Here we'll focus on the different properties that give soil its fertility or its ability to support plant growth. So let's take a look at our objectives here. Our objective today is to be able to describe the similarities and differences between properties of different soil types. So the knowledge we need in order to do that is that all soils are made up of sand, silt, and clay. Particles determine how the soil holds water and nutrients. We'll learn how to classify different soils based on their texture or the percentage of sand, silt, and clay. We also need to understand the different factors that affect water holding capacity of a soil. And finally, we'll learn about some of the basic tests that can be done to measure the fertility of a soil or how well it's able to support plant growth. Our suggested science skill for the day is to be able to describe an aspect of a research method or an investigation. So in video 4.2, we talked about how soil is made up of lots of different things. Rock fragments like sand, silt, and clay.
Sometimes it's what you don't see that makes all the difference. Look under fire lanes, grass-covered
humus, organic matter, and even water or air. So here today we'll be focusing on the geological or the rock-based portions of the soil. So when rock gets weathered, it gets broken down into tiny little particles, and we call those particles sand, silt, and clay. Now these particles have different sizes, and their size determines a lot of the characteristics of a soil. So when we talk about a soil's texture or what it feels like, what we're really talking about is the percentage of sand, silt, and clay. Because individual sand particles are so big, the space between them, or the pores, are also really big. So we can see that if we look over at this diagram here of the sand, we can see how large these individual sand particles are, which means that the space in between them, or the pores, is also going to be very large. Clay, on the other hand, is a very small particle that packs together very densely, and so the pores, or the spaces in between clay, are very, very small when we compare them to those large pores within sand. The amount of pore space in a soil is referred to as its porosity. So the more sand in a soil, the more porous it is. This makes it easier for air and water to enter the soil, which is vital for plants since the roots need to take in both water and oxygen in order to survive. So now we'll talk about something called a soil texture chart and how to use it. So all soils are made up of sand, silt, and clay, but pretty much no soil is just pure sand,
right
silt.
Here. All right, you see this chart that he's about to go over? You're going to have to know how to use that. Okay, questions are going to ask you to be able to coordinate and locate the amount of the type of soil using this chart.
Or clay. All soil contains some mixture of the three. So because the percentage of sand, silt, and clay determines the texture and the porosity, it's the main way that we classify different types of soil. So if we wanted to calculate the texture of a soil sample, we could get a sample of the soil and then set it in a jar of water and let it settle out overnight. Because the different particles have different densities, what we'll be left with in the morning is a layer of sand, silt, and clay that we can then measure to determine the percentage of each. So if we look at this example we have here in the mason jar on the screen, this is going to be 45% sand, 35% silt, and 20% clay. So let's take a look on our soil texture chart, and we would see that that lines up here in the loam category. And that's because we have 45% sand. Then if we follow this out here, 35% silt. And then if we were to follow this over, we'd have 20% clay. So this soil would be categorized as a loam soil.
Observability goes way beyond dashboards alone. It's about real-world impact.
Now I made that look pretty easy, but here are some tips for how you can use a soil texture chart to determine the classification of a soil. So the first tip is that we will always start on the bottom with the percentage of sand. Then what we want to do is move out to a point where the sand and the silt meet. So in this example, we'd move from 40% sand to the point where it meets with silt, and that's 40% silt. And then we're going to go straight over to determine the percentage of clay, and that's 20% clay. You don't want to go from 40% sand and then straight over to silt, because 40 plus 80 is 120. We can't have 120% of anything in a soil. So that's the key there. And then that last rule is make sure that it adds up to 100. If it doesn't add up to 100, you didn't do it right. If it adds up to 100, then you probably did.
Okay. Again, he's saying start at the bottom with the sand, and then whatever you decided on the bottom was your measurement, that's what you want to start with. So they said 45. And what he didn't say was you took some sand, a soil sample that was full with water, and you shook it up, and then you sat it on the table for it to settle. The thing that's going to settle first, because it's the heaviest, is the sand. And the thing that will settle out of the water next will be the silt, and then next will be the clay. And then you're going to put markings on each one, and you're going to measure the whole jar and what the markings are on each, and determine what your percentage is represented in the jar. Then you take that to the chart. So he said start with the sand. See, notice on the side there's percent silt, percent clay on that side, sand on the bottom. All right, so you start with the 45% sand. So somewhere over here with 45, roughly on this side. And you run that up till you get roughly the 35% silt, and you run them together till they meet. And they met right about in here. And then you can take that point and run it over to the clay side, and that added up to the 20%. It automatically added up 20%. If you do these two sides correctly, the clay side should end up correct also, because again, it has to add up to 100%. Okay. All righty.
So I want you to practice now by trying to find the percentage of sand, silt, and clay of this blue circle on the screen here. All right, let's see how you did. So starting at the sand, we can see that this is 30% sand. And remember, we want to go out to the percentage of silt on a diagonal, which would be 20%. And then we want to go straight over to find the percentage of clay, and that's 50%. So there we have 30, 20, 50, 30% sand, 20% silt, 50% clay. Now we'll take a look at how porosity relates to water movement through soil in a little more depth. So remember from our first slide in this video that porosity is the pore space between soil particles. So the more porous a soil is, the more easily water enters it. Well, if a soil is more porous, then it's also more permeable. Permeability just refers to water's ability to drain through a soil. So that means that water can drain through really easily if there's large pore space or high porosity. On the other hand, if a soil is more permeable, that means it doesn't hold water as well. So we would say it has a lower water holding capacity. So porosity and permeability have an inverse relationship with holding capacity, meaning the more porous or sandier soil is, the less water it can hold on to. So what does this mean for plants? Well, plants need a balance between permeability and water holding capacity. They need some degree of porosity so that oxygen and water can enter the soil and get to their roots. But if the soil is too sandy or too porous, then it has really high permeability and water just drains straight through it before the roots have a chance to access it.
Sometimes it's what you don't see that makes all the difference. Look under fire lanes, grass-covered park.
If the soil is too clay dominated though, then the soil doesn't really drain water at all, and the roots either won't get access because the water can't even penetrate the soil, or the water will penetrate the soil, but then it will stay there, and that will actually suffocate the plant's roots because they won't get access to the oxygen that they need. So the ideal state for plants is a nice medium balance between the permeability that comes with sand and the water holding capacity that comes with clay. And that's loam, which is roughly a 40-40-20 mix of sand, silt, and clay. This is really an ideal soil for many plants because it allows water and oxygen to enter the soil and drain through at a moderate pace that prevents waterlogging but doesn't dry the soil out too quickly. So if we look at this diagram here, we can see that the sandy loam, which is again a nice mixture of sand and clay with some silt as well, is going to allow water to move in. It's going to allow the water to be held, moderate water holding capacity, but it's also going to allow it to drain through. If we're looking at a more clay-dominated soil, the drainage is very slow and it becomes waterlogged, which can suffocate plant roots. And if we have a sand-dominated soil, the drainage is too rapid, so the porosity is too high and the holding capacity is too low. So again, a sandy loam is a nice, happy medium that really allows plants the proper drainage, but also the proper access to water. Now we'll look at some soil properties that affect soil fertility or the ability of soil to support plant growth. Since plants need nutrients and water from the soil, we'll look at the factors that affect each of these. So starting out with nutrients, some of the most important plant nutrients that are found in the soil are nitrogen, phosphorus, magnesium, calcium, and potassium. Factors that increase soil nutrients include more organic matter, which gets broken down by decomposers and turned into humus, which releases these nutrients for plants. Humus also improves the ability of soil to hold water though, so it's an especially critical component of soil. Then we have clay, which is negatively charged. Because many soil nutrients are positively charged, they bind to clay particles, which helps them remain in the soil and available for the plants. And finally, there are bases like calcium carbonate, which is given off by limestone, and this helps buffer or neutralize the pH of soil so that it doesn't become too acidic. One of the main factors that decreases soil nutrients is acidity. So soil that is too acidic leaches nutrients or loses them very easily when rain or other water washes through the soil. Excessive farming of the same crops from year to year can also deplete the soil because the plants use up the nutrients. And then if no organic matter is returned to the soil, and if the topsoil is eroded heavily from repeated tilling or compaction by farm equipment, then nutrients will be lost from this soil at an even faster rate. Now we'll look at water. So soil that is well aerated, meaning it has a lot of channels through it that come with organisms like earthworms burying through it, That will allow the soil to hold more water and more air. The addition of organic matter or compost or humus can also act like a moisturizing layer that prevents evaporation loss from the soil. So that will help it retain more water. And then finally, we have root structure in soil. So especially if there are native plants that have deep roots, this will really help retain moisture in the soil and prevent it from drying out. Factors that dry out soil include the compaction of soil, since there are fewer pores to hold moisture, as well as topsoil erosion and the loss of root structure.
At the Ruth Cheatham Foundation, we provide scholarships for cancer survivors so you can focus on school and your.
And the last thing we'll discuss today is soil quality tests. So we'll be doing many of these in class, but I want you to have an idea of what they are before we get to that. So soil texture, remember, is just a measure of the percentage of sand, silt, and clay that can be found just by letting a soil sample settle out in a jar of water overnight and then measuring the depths of the different layers of sand, silt, and clay. This can give you an idea of what kind of soil you have, so you can classify it as a loam or a sandy loam, and it can also tell you how porous or permeable the soil may be. However, if you want to measure the permeability directly, that's a relatively easy thing to do by just setting up a plastic column, filling it with your soil sample, and then measuring the amount of time it takes for a given volume of water to drain through your sample. Now, you'd want to do this relative to a control. This can indicate if the soil is too permeable or if it retains water for a more optimal amount of time, which will allow plants' roots to access it. Then we have pH, which is the most basic chemical test you can do on a soil. So you can just mix up a soil sample with some water, dip in a pH test strip, and this will give you an idea of the measure of the H+ or hydrogen ion concentrations in the sample. So the more acidic a soil is, generally the less optimal it is for plant growth, since acidic soils leach nutrients away very easily. Then we have color, which is a really simple test. You can just take a sample of soil and you can compare that to a color chart that you can find in something called a soil book. This will give you an idea of how much humus or decomposed organic matter there is in the soil. Remember that the darker the soil, the more humus, and generally the better that soil will hold nutrients and water that's needed for plant growth. And then finally, we can measure nutrient levels directly with various chemical tests that will measure nitrogen sources like ammonium or nitrates and phosphorus sources like phosphates. Since these are key limiting nutrients for plant growth, the more of these nutrients, generally the better a soil can support plant growth. All right, and our practice FRQ today for topic 4.3 is to describe an aspect of a research method or an experiment. So what I want you to do is try to identify and describe one test that can be conducted on a soil sample, and then explain how the results of that test could allow you to give advice to a farmer who's trying to grow crops in that soil. All right, everybody, thanks for tuning in. The most basic chemical test you can do on a soil.
So in order to answer that question, you might want to screenshot this. This is in your playlist, so you can go back and look at that again. But you need to take one of these tests that he is referring to. So I'll put those, the FRQs in the chat in a little while. Okay. In the meantime, again, look at your module. And I close mine down so I can get there faster. So you want to go back again, since you looked at soil last week, you want to do a refresher on what is soil. So we had layers of soil. Scoot back for a minute. I go back. All right, so you need to know how soil is formed and what is the technique, and there are different kinds of weathering. There's physical and biological weathering, meaning that organisms go in and break up the rock. Come on, zoom. All right. Then soil horizons. So you need to be familiar with what the horizons are, which ones will create. So what native soil is going to be rock, and rock has to break down. So eventually the rock, come on. There we go. You do need to familiarize yourself with this diagram. So the bottom layer is your rock, and that's where it would have started from. We call that the parent material. And then from there, what the weathering would take place, it would create the layer above that. And then eventually, with things falling on top of the soil, you create the humus and organic layer of the soil. But that's created so up here at the top. So when you click on these down here, they tell you what each layer is made of. So if you haven't looked at that, you should. So then you have the A layer, which is this one. It tells you what that is the topsoil. So you have your humus layer first up here at the top with all of the dead leaves and dead organisms that die on top of the soil. They create that organic matter. Then you have your topsoil. So they make the topsoil rich so that roots can grow down in it and actually get some nutrients out of the things that have died and wash down to the next level. Then you have your E level, which is kind of in between. This is what they call subsoil. Then you have your B level, or B horizon, let's use the correct vocabulary. Horizons, they call them horizons. And they consist of more minerals, but more iron. So this is most of Georgia is this red clay with iron kind of stuff. And then you have your bottom, which is the parent material or the sea horizon. Okay. So make sure you're familiar with that. The way that things get eroded, water can wash topsoil away, wind can blow it away, a glacier can slide over the surface and take the materials with it. And then we have our effects of erosion. Basically, it breaks up rocks. But remember that erosion is not how the rock is formed. Erosion is something that happens to the rock after it's or the land after it's already been formed. All righty. Coming back over here. All right, so he talked about the different types. So gravel is the biggest. So we had gravel in that soil sample, that would have been on the bottom. Then sand, silt, and clay is light stuff, and so it sits on the top. So when you have that water jar mixture, they're going to fall out what's heaviest first. So the gravel will always fall to the bottom first. Because it's heavy and gravity will pull it. Sand will fall next, because those are slightly bigger particles. Silt is kind of, think of silt like silk. It's very fine and kind of, I don't know another word to put for it. Kind of soapy, is silk, like a silky feeling to it. And then you have clay. Alrighty. And then this is the similar to what he had in the mason jar. Alrighty. And this is the pyramid that you have to be familiar with. So again, sand at the bottom, silt on the right side, and clay on the left side. And you're always going to finding a central place and coordinating the information that you collect. So make sure you read over this. And then 4.3 has also been assigned in the AP classroom. All right. So definitely read. Let me see what this one.
Today I'd like to talk about soil texture triangles. And so we're going to learn how to use a soil texture triangle to determine the type of soil that we have. So first of all, we're going to take these percentages and we're going to use this triangle. And these numbers are really handy because they're at the angle of the line that pertains to that one. Because sometimes I would get confused, like, is it left, right? And then I realized it's like this. So if you have 20, for example, you would be going down that way. And if you had 80 clay, you would go that way. And if you had 20 sand, you would go up this line. So that's kind of how we're going to do our soil texture triangle. That's how we're going to figure it out. So I'm going to go ahead and erase this so we can start with our actual sample. So we have 50% sand. Let me see if I can find a color that will show up here, but is also maybe a little darker for this triangle. 25% clay, and again, I'm gonna try maybe a darker green, just a little bit, and 25% silt. Okay, so I'm gonna start with my sand, and I'm gonna go 50%, and I'm gonna move up here like this. And I'm just gonna draw a line across because I don't really know where they're gonna meet. Then I'm gonna do my clay, and that's over here, and it's 25, so it's gonna be halfway between 20 and 30. And since these are horizontal, I'm gonna just go like this. And then our silt is 25%. So that's going to be, again, halfway between 20 and 30, and we're going to go at this angle. Okay. So you can see that all of our numbers meet right here. Let me see if I can find a better color. So all of our numbers meet right here, and that's in the sandy clay loam box. So our sandy clay loam box is this. Okay, everything in this area. Okay. So since where we meet is within the sandy clay loam, our soil is sandy clay loam. Okay, so now let's try another one. And when we do this one, what I'd like is for you to kind of try it, pause the video, try it, and then come back and watch me do it and see if you have the right answer. So we're going to start again, and we're going to do so 35% sand, 35% clay, and 30% silt.
All right, so I'm going to pause it and you practice and you tell me what you end up with before we can, and don't cheat and watch the video on your own. And then put in the chat what you believe the answer to be. What type of soil is it going to be? Sandy soil, the names of the soil will be right in the region where you end up cross-secting, where the lines cross-sect. So your characteristics, you're going to start with the sand, do the 35. So start right with this line that's right here, 35, and you're going to go up. And then you're going to take the clay, which is 35 also. So you're going to come over here and you're going to go all the way across. And then you have 30% silt, and that's about right here, and you're going to come all the way down. So then you have to look at 30 across, 35 going up. Where is it going to cross sect? What type of soil would that be? Thank you, Kayla. Okay, good. Jesse, I don't know if I say your name correctly, Arshis. Thank you. Sometimes it's the tongue twister.
So I'm going to start with my sand, and that's going to be halfway between 30 and 40, and we're going to be at this angle. So I'm just going to go through here, and I'm going to keep the words open just in case I need that one. And then we have 35% clay. So that's going to be horizontal right here because that's where these numbers are. And it looks like these might actually hit right here. So I'll leave that. I'll kind of do that. And then our silt is going to be 35. So that's going to be at this angle, just like the numbers. And we're going to come right through here. Or 30, sorry. Oh my goodness. And you see how I noticed that I made up an error? The way I was able to notice that is I was like, wait a second, these aren't all going to meet in the same spot. So I must be doing something wrong. So if you find something out like that, like you're doing something wrong, they're not going to meet all in the same spot, then you know that you've done something wrong. So that's a good way to kind of test and just kind of check yourself. So right here, all of ours meet in this clay loam box, and I'm going to kind of outline this clay loam box like this so you can see kind of where it is because it's kind of hard to see. So this one was clay loam. Did you get it right?
And y'all did, those of you who
Okay,
submitted it.
now let's try the third one. Again, what I'd like you to do is I'd like you to pause the video, try it yourself, and then start the video again and watch me do it and make sure that you did it, that you got it right.
All right, so your measurements are up here at the top: 30% sand, 45% clay, and 25% silt. So what kind of clay, what kind of soil is this one? Clay, yeah.
So let's get started. So the first one is a soil sample with 30% sand, and then we have 45% clay and 25% silt. So I'm going to do my sand again, and it's 30, and the numbers are going this way, so I'm just going to go through here. And I just made these numbers up when I made these practice problems, so they may all be the same type of clay. I don't really know. Like I said, I just made it up. And so this one is sandy loam, it's going through the sandy loam. And then we have the 25% silt. So I'm going to go at this angle because the numbers are at this angle. And I'm just going to go straight through here. Okay, so in this one, we are in the clay. Okay, because this right here, everything in here is considered clay in this box. And there are some soil texture triangles that have colors on them, but on the AP exam, it's unlikely that you'll get a colored soil texture triangle. So I like working with the black and white ones, because then if I see a black and white one on the AP exam, I know how to use it. I have experience with that. I'm not kind of handicapped by using that that colored triangle. Okay, so since we're in this clay, our soil is just considered clay. And this is because it's got so much clay in it. Okay, so did you get it right? If not, kind of think about what you got wrong and we can try it again.
All right, so that was just practice. So again, make sure that you are. All right, so one of the other characteristics of the soil is pH. This pH scale, if you've never seen a pH scale before, it goes from 0 to 14. The 7 is neutral in the middle. Everything from less than 7 is considered acid, and everything above 7 is alkaline. You don't want an acidic soil, and neutral doesn't necessarily give you the nutrients that you want. So a lot of times they want it more alkaline. So look at nutrient holding capacity and fertility based on pH. Okay. And then this one are the types of soils in the different parts of the world. And again, let's see how. Okay, we're down here in this yellow. So I'm going to have you look up, what does that mean? What type of soil is that? All right. Somebody look up this with the yellow one, because where we are right here in south of the United States is kind of yellowish. Somebody look this one up and tell me what kind of soil that is. Multi-soil. All right, thank you, Natalie. And when y'all send these in the chat, can you send them to everybody and not just me so that everybody, so Natalie, can you repeat that and just send it to everybody? So they can see that. Thank you. All right, so this is kind of soil where we are. So humid, temperate, and tropical areas, southeastern U.S. And see that that's exactly where we are, southeastern U.S. All right, so that's the kind of soil we have. All right, so again, the AP Classroom is open for 4.3. The videos there, you can watch those. Some of you have completed 4.1 and 2, but if you haven't done that, please do that first and then do 4.3. Oh, I wanted to show you, I stopped sharing too quickly. I wanted to show you, like I said, we're always known as red Georgia clay. And the picture here, that's what it was showing, is that it is known as red clay soil. Okay, one of the 12 orders of soil. So this is what our soil typically looks like. Okay, and it has to do with the mineral content of the soil. All right, I'll stop bugging you so that you can work on your AP Classroom. If you haven't completed the lithosphere project, most of you have, but if you haven't, that's due this week. Is it? Actually, it's due next week. Actually, no, it's due on the 13th. It's just open till next week, but it's due this week. So please make sure that you've completed that. Okay. I will probably go over this again next class because we got several students who are out on the field trip. But I did put the FRQs in the assignment folder. The first one, you want to start with identifying your dependent and independent variable because you need to know what it is you're testing. So start with that, and then design and invest. So clearly identify what your independent and dependent variables are, and then design an experiment to test the effect of climate on the soil formation. So again, we need to talk about formation, the layers of the soil. What would climate, so pick a type of climate that you want to test and what that has to do with the soil formation. And again, identify your dependent and independent variables. All right, on the other one, it says identify and describe one test that can be conducted on the soil. So again, you go back to the list of tests that he gave you and then explain the results that the test would allow you to give advice to a farmer. So based on the type of soil that you got from the test, what advice would you give to a farmer for trying to grow crops in that kind of soil? All right, so each of those is worth 5 points, which means take your time and develop an explanation for those. Okay. All right. That being said, I know we got about 5 more minutes, but if you're in a good place to stop, you can go ahead and do so. And again, like I said, I'll explain these again next class because several people are absent today on the field trip. All right, and then I need to put this in the module. So right now that should just be on your homepage. Yeah. Okay. All righty. So like I said, if you're good and you're ready to stop, you may go ahead and stop, and then I'll see you next class. See you Thursday. Let's see.